Hey guys, welcome to our YouTube channel Mariner's Health. Today we are here with the topic main air compressor. This I have specially made for the friends preparing for MEO class 4 examinations. So let's start with this topic. Guys, you all know how important is the compressed air on board ships. Hence, after clearing our class 4 examination, we will be joining on ship as fourth engineer or junior engineers. So, surveyor will expect a thorough knowledge of main air compressor from you. Guys, you must have seen the uses of compressed air on board ship. So, I have listed some requirements of compressed air on board ship. It is used for automations and control of main and auxiliary machineries and equipment. It is used for starting main engine, auxiliary engine, emergency generator, etc. For pressurizing the hydrofoil tank for domestic freshwater and sanitary water used in accommodation. For use in sewage plant for conducting aerobic sewage breakdowns, for soot blowing of the boilers, for use in foghorns and ship's whistle, for heaving up the lifeboat by the use of an air motor, used in pneumatic pumps for oil transfers and pneumatic driven hand tools such as grinders, chisels, drills, spanners, jacks, etc. For the use of general air for use in general cleaning and painting operations. The function of the compressor is to compress the atmospheric pressure air to the working pressure by reducing its volume. So we'll see the types of air compressor. First we'll see the reciprocating air compressor, screw compressor, vane compressor, lobe compressor, centrifugal compressors. Mostly we use a reciprocating compressor on board ship. So we will study reciprocating compressor in detail. There is a source requirement for the compressed air available on board ships. So there should be a sufficient amount of compressed air on board ships to give 12 consecutive starts for reversible engine, 6 consecutive starts for non-reversible engines. The air compressor capacity should be such that it should be able to fill the air bottle from atmospheric pressures to the working pressure in less than 1 hour. I have just shared a pictures of main air compressor which I had on my boat ship. So there are three processes of compressing the air: isothermal compression, polytropic compression and adiabatic compression. The area under this curve will represent you the work done. So as we can see, there is a least work done for the isothermal compression, polytropic compression, then the adiabatic compression. But isothermal compression is practically not possible. So we prefer as a polytropic compression. Here's the graph for the single stage air compressor cycle. So there are basically a 4 stage in this air compressors. First is the 0 to 1 is the intake, then 1 to 2 is the compression, and 2 to 3 is the discharge, and then there will be a expansion in 3 to 4. These cycles repeat. Here is the multi-stage cycle PV diagram. So it is all the processes are similar as single stage, but here we uses an intercooler between the two stages. So by using the intercooler we reduces the work done and we move nearer to the isothermal compressor. Thereby we save the work done. Now here is the working diagram of multi-stage air compressor. As the piston move from TDC to BDC, air will be sucked from the air filter. Then when the compressor move from BDC to TDC, it will get compressed and it will flow through the discharge valve to the intercooler. In intercooler, air will pass through the tubes and around the tubes there will be a water which will be cooling the air. A bursting disc is provided on the air cooler in case the tubes get hole or some problems or crack. The compressed air will leak and it won't cause a problem to intercooler. So a bursting disc is provided. A bursting disc is made up of weak material than the casing. So bursting disc will burst and protect the intercooler from damage. The question asked by the MMD surveyor is that why always air is passed through the tubes and water around the tube. The reason is there, if we pass the air around the tubes, then the compressed air will again expand, so the work done in the previous stage, that is first stage, it will be useless. So air is passed through the tubes, so it won't expand going to the second stage. After air getting cool, it is passed to the mist catcher, which will catch all the moisture content in the air before it goes to the second stage. Passing to the mist catcher, the air enters the second stage suction valve, where it gets further compressed by the second stage. Again, this compressed air passes to the delivery valve and goes to the aftercooler. This line also has a relief valve for the safety. After this air passes through the aftercooler, which will get cools, and again it goes to the mist catcher. After passing through the mist catcher, it goes to the air bottle, but in between the air bottle there is a non-return valve. The reason of giving this non-return valve is to prevent the flow of the air from air bottle to the compressor, because in case if the filling valve of the air bottle leaks and the compressor is stopped, the air will flow from air bottle to the compressor and whole the air bottle will get drained, because when the compressor is stopped, the unloaders are open, so all the air will be vented to the atmosphere. So here we completed the whole cycle. Here I have set a pictures of the intercooler. So here you can see that intercooler has relief valve and bursting disc. Relief valve is provided on air side and bursting disc is provided on water side. So the function of the bursting disc is to burst when there is a hole, so high pressure air will flow in the water side and it will burst the bursting disc and protect the intercooler. If valve lift when there is some problem in the system, it is set at 10% of the working pressure. It is provided on both the intercooler as well as aftercooler. So now we will start with the question answers which been asked by the MMD surveyor. So most common, I have collected the most common question asked on the air compressor by the MMD surveyors. So these are the questions. Let's discuss one by one. The first question is that why the single stage compressor is not preferred for 30 bar compression? Why multi-stage compressor is used? What is the use of intercooler and aftercooler? There are many problems with the single stage compression. First is the low volumetric efficiency, heavy component requires, thermal stresses are also high, cooling will be the problem, oxidation of lube oils. One of the major problem is the volumetric efficiency. Guys, we know that 30 bar compression is very high compression. So when the air is compressed and the piston is at TDC, there is some of the air trapped in the clearance volume. Now this 30 bar air will try to expand when the piston moves from top dead center to bottom dead center, and this expansion won't drop the pressure, it will be higher than the atmospheric pressure, so another fresh air will not come inside the compression, so thereby this reduces the volumetric efficiency. A part of that, a heavy component will be also required because we are going to compress this such a high expansion ratio. Then cooling will be the problem, there will be a lubrication will be a problem, all the lubricating oil will get burnt and it will form a lacquer inside the compressors and compressor walls, and this will be the major problem. So we don't prefer a single stage compression, so we go for the multi-stage compression. All the problems related to the single stage compressors are being solved by multi-stage compressor. In multi-stage compressor we use intercooler as well as aftercooler. Intercooler cools the first stage air before passing it to the second stage, thereby reducing the work done. Then the aftercooler cools the air outlet of the compressors before it goes to the air bottle, thereby reducing the temperature of the air, so thereby reducing its volume, so therefore more air can be stored in the air bottles. Now second main question is, what is volumetric efficiency, reason for decrease in volumetric efficiency, what is bumping clearance, what if increase or decrease, how can we measure? So guys, volumetric efficiency is nothing but the ratio of air drawn inside the cylinder to the swept volume. So here are the various reasons for decrease in the volumetric efficiency. First is the bumping clearance, second is the defective valve, third is the filter choke, fourth is the cooler fall, and fifth is the piston ring or liner worn out. So these last four reasons you may well know, but I want to specially tell about the bumping clearance increase. If the bumping clearance is increased, the more amount of air, compressed air, will be trapped in these clearances. So when the pistons move from TDC to BDC, this air will try to expand and won't create a pressure drop faster inside the cylinder. So therefore late fresh air will come inside the cylinder, so less amount of air will be sucked inside the cylinder, so thereby reducing its volumetric efficiency. Now how this bumping clearance is increased? First is while maintenance we place wrong thickness of the gasket between the cylinder head. Then second is worn out main bearing of piston bottom end bearing or gudgeon pin bearing. I have just shown the where these three bearings are been placed in the figure, so just try to see the figure. Third important question is why second stage is smaller. As pressure of air increases, the volume of the air decreases and the mass flow rate of the air remains the same throughout the cycle. So volume occupied by the air is also decreases, therefore diameter is also decreases in each stage. The fifth question is the properties of lube oil used in main air compressor. One of the main properties of lube oil is it should have anti-oxidation. So in main air compressor we use a synthetic oil which is chemical composition base which have very low oxidation rate, thereby reducing the carbon deposition and lacquer formation. Safeties on main air compressors. This is the very important question and definitely surveyors are asking this question to each candidate. First is the relief valve, second is the bursting disc, third is the low lube oil pressure trips, third is the high air temperature trip, fusible plug, motor overload trip and unloader. Now I'll explain you the one by one in details. One is the relief valve. Relief valve is provided on the intercooler and aftercooler. These are set at 10% of the working pressure. Then second comes the bursting disc. Bursting disc is provided on the water side of the intercoolers. Third is low lube oil pressure trip. If something goes wrong with the lube oil system, that is lube oil pump, so this will trip the compressor and won't allow compressor to run dry, thereby safeguard against the bearings of the main air compressor. Fourth trip is the air high temperature trip. If the air temperature goes above the limit, it will trip the compressor because high temperature air will go inside the air bottle and it will start expanding the air. To avoid this, we provide high air temperature trip. Then comes the fusible plug. If the high air temperature trip won't come into the action, then fusible plug will come into the action. This fusible plug is made up of low alloy material which will melt at 105 degrees Celsius and will release the air to the atmosphere. Then comes the motor overload trip. In case if there is a seizure or in case there is any reason there is a overload on the compressor, so it will trip the motor, because if there is a overloading it will draw excess current and it will cause damage to the winding. So for safeguarding this we provide a motor overload trip. Then there is a unloader. Unloader is used to reduce the starting torque on the motor. It will unload the cylinders by reducing the starting current, and when it reaches to the 85%, it will load the cylinder and it will start compressing. But now the last question is that how to check the performance of main air compressor. So this can be done by noting down the filling time of the air bottle from atmospheric pressure to the working pressure. It should be less than 1 hour. So in this way we can check the performance of main air compressor. Thank you friends. Hope you liked my video. Please like and share and subscribe to my YouTube channel Marina's Help. I'll be posting new other videos which will be helpful to your examination. Please comment what topics you want me to cover. Thank you.